something about wearable technology, but I couldn't get anything very impressive to work, just a hat. So I'm going to show and tell us something about some work I've been doing with a guy from the National Library of Wales who's doing work on the Cyffredin Williams collection. Cyffredin Williams is a Welsh landscape painter who's painted lots of landscapes in and around the Snowdonia and Wales, and also Patagonia, but I'm not so interested in those because they're too far to go and look. And this entire research project grew out of meeting someone in the bar at the Coops. So drinking is good for research. That's my key take-home message from this part of the talk. Also, anyone who was at the Vision Group talk today, this talk was created from that talk by application of the delete key, so I apologise now for the repetition. So these are two Cyffredin Williams landscapes from Cadair Idris, the top of Cadair Idris. Clearly count the lake at the top of Cadair, and these two paintings are at the same place, separated by about 50 years in the painter's life. So you can see that the style has changed over time, and the colours he's choosing to use have changed over time, and so on. And what my research is computer vision. So what I do is I take digital pictures and video and try and work out what's going on in them. And when I met a guy who was trying to geolocate paintings, I thought, well, you can geolocate a photograph, so why not a painting? So, here we go. Step 0, find some other images of Cadair Idris. I did a Flickr download of all photographs tagged with Idris, Cadair Idris, both English and Welsh spellings, and you get a data set of about, this is high risk, is this going to work? Hey, it's working. So you get about 300 pictures, and the first thing you notice is that there's a couple of false positives due to the fact that Idris was an Islamic prophet. So as well as having pictures of a mountain in Wales, you've got lots of small Asian boys and a load of mosques. And it's just a little bit, and I don't know who that guy is, but there you go.
Did these screw your results?
No, my code worked really badly, but not that badly. So, I've got these images of Cadair Idris from the real world, and what I want to do is match those with paintings. So the first thing I did was a stupid thing, which is just take each pixel in turn and calculate the Euclidean distance in RGB space to the nearest, the same pixel in the actual image. And this is the best RGB Euclidean distance matches for Cadair Idris. This is the best match for this painting. You can see it's not the same place, but there's obviously some visual similarities. And this is the best match for this painting. Again, it's a tree, that's a mountain. It's not too bad. Yeah. So, the next thing I thought is, well, one of the problems is colour. So, Cyffredin Williams as a painter used a various range of colours that were not using the entirety of the colour sphere. I think we can safely say that he's got a preponderance of yellowy greens, and a bit of blue, mostly in the Patagonian phase. This one's a Patagonian painting. And so I thought, what if we can model the colours that this painter's using and use that to change the mapping that we're doing in between the photographic images and the paintings? So there's some hard suns. And what I'm trying to do is I'm trying to model the colours that the painter's using as a mixture of Gaussian. So I'm trying to model using statistics, the statistical distribution of colours within this particular painter's work. This is the point where I got slightly distracted, but I basically built a statistical distribution of the way Cyffredin Williams used colour, and then used closest match to that statistical distribution to recolour the pictures. So the one on the right, is that the right? That's the right. That one?
Left.
Okay, I'm not going to do that. That's the original. And this is the recoloured one. So you can see it's come down a bit in brightness and so on. And I'm going to show you a video now. Actually, no, I'm going to show you a number of videos because why not? So, you all know about the colour cube, yeah? Which is the idea that you can represent colour space as a cube with red at the top, green at the right, and blue at the back. And what we're doing here is we're traversing backwards through the colour cube, and this is showing you the entirety of RGB space in one 255 frame video. Everybody got that? Great. Next one.
Will this be on the test?
This is the colour cube that you get if you learn a distribution from Coughlin Williams pictures and colour each point in the colour cube. Did that register? Is it behind? It's behind. So I'll start that again. So I'll start it again when it stops. It's easier. It's very quick. So this is colouring each point in the colour cube with the closest point in basically Coughlin Williams space. So it's
Yellow.
it's yellow, it's grey, there's a bit of blue, there's not much green, there's hardly any red. So what I'm doing is I'm recolouring the images with this. And the point at which I went down a bit of a wormhole was when I realised, well, if I can find a load of Coughlin Williams images on the web and build up a model of his colour space, what do other people look like? So, here's Constable. And you can see again, it's not using the whole of the colour space, but it's a little bit more spread out and so on. Here's David Hockney, who's uses a much more uniform distribution within the colour space. And you can see that the way these painters are using colour can be statistically modelled just through expectation maximisation and a Gaussian mixture with 30 components and colouring with the most significant of those. I'll go back to hard samples and I'll watch that in a bit more detail. So what's the nearest neighbour after the colour transformation? Well, the nearest neighbour for this one after the colour transformation is actually a lot better, I reckon. It's a mountain, it's got a lake, it's got some stuff, it looks a little bit more like what we're dealing with. And for the other painting, it's the same one. Very much a work in progress. One of the things that happens with these things is with paintings and artists when they represent spaces, they don't represent in the same way that a camera represents. This is trivial knowledge. And this is a painting by David Hockney called Garraby Hill, which is in East Yorkshire. This is a photo from the top of Garraby Hill. And it took us a long time to find where we thought he'd taken the painting from. And then we took a photo, and you can kind of see there's some similarities, but he's not really painting in the same way. Coughlin Williams does spatial distortions in a similar way, but not quite as extreme as the late Hockney stuff. But I think that's going to be my big problem with taking this any further. But anyway, that's basically the idea. So one thing that might help is a better set of photographic images. So one of the things I'd like to do here is recruit people with cameras to come up Cadet Idris on sunny Saturday to take as many photos of Cadet Idris, trying to get things that might match this particular scene. So I'm going to find a piece of paper and people can put their email addresses on it and I'll sort that out. And that's my talk. And I too don't have much interest in Arduino because I've already got one on my hand.